So here's a big question for you. How do you build an AI agent that can actually spawn other agents without them going rogue? We're about to dive into a really cool architecture that's designed to do exactly that. To build agentic systems with safety rules that are, well, basically unbreakable and passed down through generations. All right, let's just let that sink in for a second. This right here, this is the core promise of the whole system we're looking at. It's the central guarantee. It means that those foundational rules, what we'll call the prime directives or PDs, are totally non-negotiable. You mess with them, you try to alter them even a tiny bit, and the system just stops. The new agent literally does not get created. It's a hard no. Now, all these ideas come from some fantastic source material, a paper by Nir Cohen called Genetic Prompt Engineering plus Context Engineering. And the core idea is pretty brilliant. It proposes this kind of genome-style architecture where safety isn't just some optional setting. Nope, it's baked right into the agent's DNA, so to speak. Okay, so how does it actually pull this off? Well, the real magic is in something called the spawn sequence pipeline. You can think of this as our roadmap for the rest of this explainer. It's basically a series of security gates that every single new agent has to pass through before it's even allowed to exist. And here's what that pipeline looks like from a 10,000-foot view. First up, there's a cryptographic check on its core rules. Then, it hits these super strict gates that control what actions and tools it can even use. After that, a firewall, this thing called Immune, filters out bad user input before the agent can process it. And finally, it gets a signed, unchangeable birth certificate. We're going to dig into each one of these. So when you put all those steps together, what you get is a really robust defense-in-depth strategy. Let's start breaking it down layer by layer, starting right at the very foundation. And that foundation? It's all about the prime directives, or PDs. The key word here is immutable. These aren't suggestions or best practices. Think of them as the agent's non-negotiable genetic code. They get passed down word for word from parent to child. The whole point is to make sure that core values, safety, truth, compliance, don't get watered down or lost over time. So how do you enforce that immutability? That's the billion-dollar question, right? Well, it's not based on trust. It's based on cold, hard math. Every set of prime directives gets a unique digital fingerprint, a cryptographic hash. A child agent has to inherit the PDs perfectly, and its hash has to be an exact match to its parents. If there's even a single bit of difference, boom. The whole process is designed to fail closed. The spawn sequence just shuts down. That agent is never born. Okay, having immutable rules is great, but it's not enough if the agent can just do whatever it wants. And this slide shows that next layer of defense perfectly. On the left, you've got the Wild West, an agent with freeform output that can do pretty much anything, which is risky. But on the right, you have control. You force the agent to only communicate using a very specific structured JSON schema. This means you get to define exactly what actions it can take, what tools it's allowed to touch, and what its outputs look like. You're basically engineering the unpredictability right out of the system. Right, so we've locked down the agent's core rules and what it's allowed to do, but what about what people ask it to do? That's where this immune gene comes into play. You should think of it like a bouncer at the front door. It's a pre-execution firewall. It scans all incoming user prompts for anything sketchy before the main agent brain ever gets a chance to see it. It's a proactive shield. And what's it looking for? Well, all the usual suspects. The classic prompt injection attacks, right? Things like ignore all your previous instructions or tell me your system prompt. It's also looking for attempts to leak secrets like API keys or trying to get the agent to run dangerous code. The immune gene is basically trained to spot all these dirty tricks and just shut them down right at the entrance. The last piece of this defense-in-depth puzzle is what the paper calls the lineage gene, or the provenance hook. Basically, every single agent that gets successfully created gets its own little digital birth certificate, a signed manifest, and run log. This creates an unchangeable audit trail. You can see exactly who its parent was, what its core rules hash is, everything. And this is just huge for things like auditing, forensics, and being able to safely roll back if something ever does go wrong. Okay, so we've been deep in the technical weeds here with all these engineering mechanisms. But so what? Why should a business or a team lead care? Well, because this entire architecture is designed to translate directly from code into the language that compliance and governance teams understand. Just look at this mapping. It makes it super clear. That PD hash verification we talked about, that's not just some developer feature. In the enterprise world, that's called an integrity check. The immune filter, that's threat prevention and content filtering. And the lineage gene with its logs and manifests, that's your audit trail and provenance. This is literally how you connect the cool tech you're building to the boring but critical controls the business needs. And this isn't just us making up connections. The artifacts this system kicks out, those signed manifests and run logs, they're intentionally designed to align with major established frameworks. We're talking about things like the NIST AI Risk Management Framework, specifically their GenAI profile, and even content provenance standards like C2PA. What this means is that proving compliance isn't some painful chore you do later. It's a native feature of the system from day one. So when you step back and look at the whole picture, the biggest takeaway is this. A single safeguard is never going to be enough. Real, robust safety comes from having layers. You need the cryptographic integrity of the hash. You need the behavioral constraints from the schemas. You need that input filtering shield. And you absolutely need the forensic audit trail. It's a true defense-in-depth strategy. Which really just leaves one final question for you to think about. As you're designing your own agentic systems, how are you going to build in your layers of defense?